Well, what about other planets? How about Venus? Earth is volcanically active, as we know. Venus is nearly the same size, doesn't have a moon to be doing tidal forces. But Patrick, do you think that Venus has? What's the latest there?
All right, well, let's take a look at Venus. As you can see here, this is an image taken back in 1974 by the Mariner 10 spacecraft. Venus is completely covered in clouds, and it's the reason why Venus is the second brightest object in our night sky, mainly because the clouds reflect almost 90% of the sunlight. But those clouds are really thick. There's a 15-mile cloud layer, making it difficult for us to see any type of geological or even volcanic activity on Venus's surface. Now, if we were to be on the surface, as in this graphic here, it is not a very pleasant place to be standing on. The temperature is almost like a pizza oven down on the surface, not to mention that the atmospheric pressure is 90 times that of Earth. It's like being underwater at a depth of 2,625 feet. So really crushing atmosphere, and the atmosphere itself is not breathable. It was pure carbon dioxide, and the clouds above made of sulfur dioxide and sulfuric acid. So anyway, with all of that, how can we even determine what's going on geologically on the surface of Venus? Back in the 1990s, and we're going to turn to this spacecraft was launched by the space shuttle. It's called Galileo. And Chris, you had some connection with this mission.
Yeah, this was one of the very first missions that I supported when I worked for Rockwell. And it was the first time that a space probe was launched from the space shuttle. So the Magellan mission to Venus was a big, big deal for us when Atlantis got it launched safely.
Well, Chris, I thank you for those efforts, because this spacecraft traveled a few million miles away from Earth and from the space shuttle. You can see that there's a big radar dish that would be able to send radar and bounce it off the surface of Venus. And basically, it will penetrate the clouds. And what Magellan did in its 4-year mission around Venus was map 98% of the Venusian surface down to a resolution of 390 to about 985 feet. That was incredible. It gave us an incredible view of the surface, and you can see it's very varied, and sent us back altimeter data, so we could use that data to create these incredible 3D views of various features would look like on the surface. We're looking at Mat Mons, one of the largest volcanoes on Venus. And yes, it's a volcano. In fact, scientists took all of the Magellan data and tried to identify all the volcanic features of Venus. And they made this map, which shows that Venus is plastered with volcanoes. There are more volcanoes on Venus than any other planet in the solar system. And there are various types, some of the large shield volcanoes down to small volcanoes, and even volcanoes that look like pancakes or corona type volcanoes. So do we have any evidence that these volcanoes are active today? Is there any recent activity happening? In fact, right now as we speak, and if you were looking at Venus today and in the evening sky, is there a volcano or several volcanoes erupting? Well, we only have clues, and these clues came from a spacecraft called Venus Express. It was in orbit around Venus from 2006 to 2014. It carries an instrument that can detect infrared. This image was made from data from Venus Express, showing a signature of infrared heat from a volcano called Idun Mons. That is giving us a clue that there actually is some volcanic activity, whether it's actually erupting or not, but you have some telltale signs here. Apart from that, there have been some recent papers suggesting what we should look for in terms of clues of volcanic activity on Venus. This paper says that there's a role in phosphenes. We did a story last year, it was a big story, that phosphenes were found in the atmosphere in the clouds of Venus. Scientists were excited because it's basically like a biomarker and the signs that there might be microbial life in the clouds of Venus producing phosphine. That debate still rages on among scientists, But there might be another mechanism that the source of this phosphine might be from explosive volcanoes that are happening right now on Venus. So
Mhm.
future space missions should be looking for a geological or a volcanic source of phosphines. There's another paper that scientists combed through the Magellan data and looked for various structures for deformations left by volcanoes. As a volcano grows, it deforms the ground around it, mainly because of its mass. The more the deformation, there are signs that the crust is thinning, giving us an idea that there might be more heat flow and that area might be young and volcanically active. They did a study on this particular corona type volcano called Arimati corona. And so the degree of definition can offer clues of how young or how old a volcano might be. The problem is that the data that was gathered by Magellan is 30 years old, basically being combed through, and literally we're running out of data and we need new data. So what's next? Well, just recently, NASA announced 2 missions in its Discovery program just a few months ago, missions to Venus. One is a mission called Da Vinci Plus, which will send a space probe through the atmosphere of Venus and land on the surface and sample the composition of Venus's atmosphere. And then there's this mission, which is Veritas, a mission to map in very high resolution the surface of Venus using the same kind of radar technique that Magellan used 30 years ago. But now technology has advanced. We can even map with even more precision than ever before. This mission will be launching between 2026 and 2028, being in development now. And it could offer us some clues to whether or not Venus is volcanically active. And this is just an artist's illustration of what we want to find out about the surface of Venus. It also carries an infrared detector as well to seek out heat sources and heat signatures from its surface. So together, all these instruments will provide us with data on the planet's past and its present geological processes. The data gathered could be a model for Venus-like exoplanets as we find elsewhere in our universe. So very exciting development.
It seems to me with all those volcanoes, Venus could be the most volcanic object in the solar system if enough of them are erupting. We'll have to see. It